Okay, so here is the second portion of our equilibrium discussion, and this is going to be a little bit shorter because what we're going to focus on here is something called LeChatlier's principle. So LeChatlier's principle says that when a system is at equilibrium, and remember this is our signature for an equilibrium system. When a system is at equilibrium, if the system is disturbed, the reaction shifts to reestablish that equilibrium. Remember that equilibrium is a constant, that constant K, right? And so again, it has to reestablish equilibrium. So if you were to add an amount of product, NO2, in this reaction, it would have to go in that direction, right, to reestablish K as the equilibrium constant. So here's kind of a more complicated way to describe all that, right? If you were to add more NO2 to this system, right, it would have to redistribute, right? And that redistribution would cause the system to shift to the left, and that shift to the left would create more N2O4 and less NO2, and it would get back to a point where the K was satisfied again. Stands to reason then, if you do it from the other direction, if you add more reactant, then again it's going to have to shift to the right, and we're going to reestablish that equilibrium. So now if we talk about gases, when we talk about gases, there is a applied pressure that we can talk about. And when we increase the pressure in a system, the reestablishment has to actually move to the side with less gas particles. So increasing pressure would push this system towards the products, which are the ammonia gas, because there's only 2 moles of ammonia gas, and there are 4 moles of the reactant gases. So increasing pressure shifts this to the right. The opposite effect when pressure is decreased, so reducing pressure actually shifts the reaction to the left towards reactants, because there is now more space, if you will, right, for those 4 moles of gas to distribute. So we can add in some other things to this, and we can say, heat is given off in this reaction, and so we treat heat in a similar way as we treat the product. And so heat is on the product side, and if we then look at the heat on this side, we add heat to this system, it's going to end up shifting it towards react. In the same way, we can remove heat from the system, and this is actually a technique that's used quite frequently in industrial settings. So if you can remove the heat, then you can shift this equilibrium to the right and get more product. So if this is an endothermic reaction requiring heat, then the more heat we add to the reactant side, the more we shift the equilibrium to the product. So this is just a picture of that experiment, and on the left side, reducing the heat, you get more N2O4. On the right-hand side, you get more of the brown NO2. Again, it should make some sense that the opposite of adding heat, shifting it to the right, if you remove heat in this scenario where heat is considered or is being treated as a reactant, then it's going to shift to the left. Okay? All right, so that wraps up LeChatlier's principle.